Welcome back to the topic of purification and separation techniques. Now, before we go on to introduce all the other techniques, let us recap what a solute and a solvent is. So, if you're dissolving salt in water, which one will be the solute and which one will be the solvent? So if you recall, the solute is the one that you put into the solvent, or in this case, the liquid water. In this case, the solvent is the liquid usually, or sometimes it's a gas, in which you put the solute in. And after you dissolve it, you will get a solution. So if you recall, a solution is one that is homogeneous or evenly mixed, but suspension is non-homogeneous, which means that if you look at a suspension, it's a bit like bubble tea. You know, the color and the density at the bottom of the tea is different from that at the top of the tea. And of course, when left standing, all the pearls will separate from the liquid. But if it's a solution like salt water, the salt does not separate from the water. So let's do a quick quiz to recall and help us to remember which ones of these are or are not solutions. So we have perfume, hand sanitizer, Coke, and none of the above. So actually, all of the above are solutions. Now, a fizzy drink or like Coke or even wine has different kinds of substances that dissolved in water. And you don't necessarily have to have a solid that dissolves in water. A gas can dissolve in water as well, like carbon dioxide in water, so that's how you get your fizzy drinks. Perfume and hand sanitizer has substances dissolved in alcohol. So solutions do not always need water as a solvent. You can have alcohol, for example, and solutions do not always need to have a solid dissolved in a liquid. It can be gases or liquids dissolved in a liquid as well. Another quiz. So which of these are suspensions? All in water, orange juice with orange pulp, smog, and bubble tea. Now all of the above are suspensions. So I think you realize that juice pulp definitely doesn't dissolve in water, neither do the tapioca balls. And dust particles in air, you actually can visibly see the dust particles, especially when there's haze or smog. So they're definitely not a homogeneous solution. And the thing to take note is that air can be a solvent as well. You don't necessarily need to have water. And oil and water, okay, either of this can be the solvent and either of this can be the solute. Okay, and definitely they do not dissolve in one another and it's not homogeneous because you have oil here and water here. But usually we don't call it a suspension, we call it immiscible liquids, meaning they do not mix. So miscible liquids mix, but immiscible liquids do not mix. So do take this down as well, the term immiscible and miscible. So now we're going on to the various methods of separation, and the first 4 or 5 are actually recaps. So for the first one, let's think about how you obtain salt from water. So not water, but if you want salt. Now you should remember that evaporation can be used to separate soluble solids from a solvent. So you heat the mixture, for example, salt water in an evaporating dish, and the water evaporates and you are left with salt. So we have seen this in last year, I think, that in countries that have a lot of sea water and a lot of space, they actually get salt or sea salt, the thing that you actually eat rather than table salt. is gotten by evaporation of water from seawater. Now, another way we can get a soluble solute from its solution is through crystallization. It is similar where we heat the solution in an evaporating dish. However, we heat it to evaporate only part of the liquid. Then we cool it down to room temperature slowly. But how do we know how much to evaporate, right? You know when you get a saturated solution. Let us try and recall what does it mean when a solution is saturated. So a solution is saturated when it contains the maximum amount of solute that can dissolve in that amount of solvent at a particular temperature. So the key point is that when a solution is saturated, no more solute will be able to dissolve in the solvent. So it means if you're dissolving salt in water, a solution is saturated when you can't dissolve any more salt in the water. So this is like eating, right? Imagine that your stomach has a fixed amount of space and you try and stuff, usually maybe we can stuff 4 McDonald's breakfasts into our stomach. Okay, but one day you want to stuff 6 McDonald's breakfasts in your stomach, and of course, all of it comes out the other way. So, how does crystallization work? So, when you actually heat up the solution, it's like expanding your stomach. So, initially, you can have maybe this amount of salt inside the solution. Maybe I'll just draw 3 of them. 3 grams of salt. But when you heat it up, okay, you can actually have 5 grams of salt. I represent it by 5 circles. Okay, when you heat it up. But if you cool it down again, it can only hold 3 grams of salt. So the rest of it must come out as salt. And if you cool it down, it actually comes out as crystals. So we're going to go through the process of crystallization, and these steps are very important. You usually are tested on the procedure for crystallization, so do write it down in your notes. So first, the solution is heated to remove most of the water, and heating is stopped when a saturated solution is formed. So usually you test for saturation by sticking a glass rod into a saturated solution, and when you take out the glass rod, crystals will start to form. That's when you know you stop heating. Then you will cool down the hot saturated solution and you'll get nice crystals forming. The last step will be to wash the crystals with cold distilled water. Now, why cold, you would ask? Well, if it was hot water, it's essentially like dissolving the crystals back in water again. So you don't want the crystals to dissolve again, so you wash it in cold water. Now after that, you dry them by pressing them between pieces of filter paper. Now, since evaporation and crystallization both gets you the solid, what's the difference? So firstly, do take this down in your notes as well. Okay, that evaporation, if you realize, you will get the solid in a powder form, but in crystallization, the solute collected is in crystal form. So it contains the water of crystallization. And of course, in order to get the solute in the crystal form, you only evaporate part of the solvent, so you form a saturated solution. But for evaporation, the mixture is evaporated to dryness, so you evaporate and boil off all the solvent. So now we're going to have a quiz. Do fill in the blanks for the helping words for B, D, and E. And what we're going to do in the quiz is that you need to reorder the steps for evaporation, dryness, and crystallization, and key in your answers. And here are the answers to give it a check. And we have come to the end of the video.